Hello everyone, I am Mingxu Xiang from Chongqing University, China. I'm very glad to have a chance to share our recent research. The topic of my presentation is hierarchical AGC dispatch with aggregated resources. I will introduce this research from these four aspects. First is the background. The development of renewables is an important way to achieve the goal of carbon peak and carbon neutrality in China. However, renewables are uncertain and fluctuant. The large-scale integration of renewables could bring a large burden to the real-time balance and threaten the frequency performance. Promoting energy storage systems to participate in AGC dispatch is a solution to handle the frequency challenge. However, the application of the energy storage system is restricted by two problems. Problem one is that the capacity of the energy storage system is relatively small, which cannot meet market access rules. Meanwhile, involving numerous energy storage systems in AGC will increase the computational burden. Hence, it is necessary to aggregate energy storage systems. Problem two is that the frequent power adjustment for frequency regulation will cause the lifespan degradation of energy storage systems. Regarding problem one, firstly, we give the concept of aggregation, which is calculating the Minkowski sum of regions representing the regulating capabilities of energy storage systems. However, all combinations of vertices need to be enumerated. The computational burden is exponentially increased. To improve the computational efficiency, the existing methods preset the shape feature of the feasible region. However, the calculation accuracy cannot be guaranteed. Regarding problem 2, existing studies embed the lifespan protection strategy into the heuristic method. However, the regulating capability and regulating costs cannot be comprehensively considered, and the regulation behavior lags behind the power fluctuations. To address the drawback of the heuristic method, the proactive AGC dispatch method is proposed. This method establishes a detailed optimization dispatch model to handle the forecasted power fluctuations. However, this method is dependent on the forecast accuracy of the power fluctuations. In addition, the degradation of energy storage systems is not considered. To handle the aforementioned problems, we propose a hierarchical AGC dispatch method with aggregated resources. I will introduce this method in the next part. Firstly, we propose the resources aggregation method with guaranteed accuracy. The basic idea is that the regulating capability of a single energy storage system can be equivalently represented as a polynomial zonotope. In this representation, the aggregation principle for each classification of the parameter is simple. The accuracy of the proposed method is high because the transformation between the traditional vertex representation and the novel polynomial zonotope representation is equivalent. The efficiency of the proposed method is high because the simple principle. The calculation process of the proposed method is shown on this page. It mainly contains three parts. Firstly, input the regions of regulating capabilities to be aggregated. Then, to obtain the regions to be aggregated, the parameter transformation stage transforms the vertices of each region into Z-rip and calculates the convex hull of each region under Z-rip. Finally, the region aggregation stage calculates the Minkowski sum of Z-rip regions and output it as the final result. This page further proposes a polynomial zonotope-oriented parameter transformation method of regulating capability for the second stage in the previous page. The essence of the proposed method is calculating the convex hull of vertices with a polynomial zonotope representation. After the aggregation of energy storage systems, a hierarchical AGC dispatch method is proposed, which combines the advantages of heuristic methods and proactive methods. Two stages are contained. The first is the proactive dispatch stage. This stage aims to handle the forecasted power fluctuations. Thermal power units mainly participate in this stage to alleviate their drawbacks of snow regulating speed. The second is the real-time dispatch stage. This stage is based on the monitoring data, which can address the forecast error at the unforeseen fluctuations in proactive dispatch. The lifespan protection strategy is embedded in both two stages to alleviate the degradation of energy storage systems. In the proactive stage, a detailed optimization dispatch model is established. To alleviate the degradation of energy storage systems, the proactive SOC recovery strategy is embedded. Besides, to alleviate the negative effect of sudden power changes on the system frequency performance during SOC recovery, a linear wrapping mode of energy storage systems is used. There is a total of three linear wrapping circumstances to describe the SOC during these three circumstances without increasing the complexity of the SOC model. A uniform SOC model is established. However, for circumstance C, there exists an error item. Through theoretical analysis, we find that the modeling error is acceptable. In addition, the power of energy storage systems in proactive dispatch should nearly recover to zero when SOC recovery is completed, which could also cause a change of the SOC. Hence, the SOC model should consider the power recovery process. In the real-time stage, the heuristic method is used to allocate AGC commits determined by monitoring data. The forced SOC recovery strategy and the databed of energy storage systems are considered to alleviate lifespan degradation. Next, case studies. The effectiveness of the proposed aggregation method is verified while aggregating 40 energy storage systems. Three methods are compared. It can be seen that under the premise that the computational requirement can be met, the proposed method can achieve a large improvement of the aggregation accuracy. Next, the effectiveness of the proposed hierarchical AGC dispatch method is validated. 7 methods are compared. In the IEEE 30-bus system, it can be observed from the table that the proposed method can achieve good performance regarding the frequency performance, the degradation of energy storage systems, and the operating costs. Besides, the calculation time of the proactive AGC dispatch model can meet the computational requirement. Similar conclusions can be drawn in the practical utility system. Finally, the conclusion is drawn. Firstly, a regulating capability aggregation method of energy storage systems based on polynomial zonotopes is proposed. Simulation results show that the proposed method can improve the aggregation accuracy while the aggregation efficiency is acceptable. The surrogate constraints obtained by the proposed method provide the model basis for the AGC dispatch. Then a hierarchical AGC dispatch method with lifespan protection for energy storage systems is proposed. Simulation results demonstrate that the proposed method can ensure the system frequency performance while alleviating the degradation of energy storage systems. The proposed method shows the potential to promote the application of energy storage systems in AGC dispatch. That's all my presentation. Thanks for your listening.